Today, I'm talking about charging ports of electric vehicles. As autonomous vehicles become more common, it's possible that fleets of autonomous vehicles will replace buses for public transport. Since these will be electric, it will be important to schedule regular charging. In order to efficiently using electric vehicles, we need to get vehicles to the start of a journey in time for customer to minimize deadheading. Also try to prevent out of storage on a journey. Our contributions include the following fourfolds. First, we consider battery usage and minimum charge level for electric vehicle operation. Second, we reduce the computation cost by considering different look ahead for model predict control and different integer constraints. Third, we compare energy used and average delay for customers when choosing different fleet size. Four, we consider location-dependent charging rate. The objective of optimization problem is minimize customer waiting time, empty traveling, and cost related to charging. The problem satisfies constraint about state of vehicle, variable bound constraint, and battery constraints. The battery constraints include stationary time need to be sufficient for charging and grid support, and charging need to be sufficient for mobility and grid support. Our research considers the use of model predictive control to coordinate charging to carry passengers. For these methods, optimization problem is solved at each time step to yield a sequence of control action up to a fixed horizon, and the first control action is executed. We use a 3-stations network to illustrate our results. In the first figure, the blue lines means average energy used as we vary the number of vehicles. And 6 red curve means average delay for customers on 6 different routes. As expected, we can find the larger fleet size decrease passenger waiting times, but energy consumptions increase. In the second figures, when using model predict control method, we try relaxing some of the ones at the future times to reduce computation. The lower value of objective functions means better accuracy. In the legends, 7 T1 to T5 means that we use a horizon of 7 and the first 5 steps had integer constraints. And we find that there's a trade-off between the computational complexity and the accuracy of solving the MPC problem. In conclusion, model predict control provides an adequate method for scheduling charging and motion of a pool of electric vehicles serving as public transport.